modern car's most important strength and safety components. This is how you make one. You start with a pile of sand, because sand is what glass is made of. You add dolomite and soda to make the sand easier to melt. You melt it. Sounds easy, doesn't it? But the truth is, glass manufacture happens on such a huge scale these days. Only a few companies in the world have the equipment, experience and investment to do it. At this giant plant, enormous quantities of sand, dolomite and soda are blended automatically and sent into a vast furnace that's 1100 degrees Celsius inside. The melted sand is floated onto molten tin. The sand mixture gradually cools as it goes along on top of the tin, becoming glass. The tin gives it a really smooth surface. The faster it goes, the thinner the glass. Windscreen glass is pretty thin, so it travels at about 1 km/h. Here's the continuous sheet of glass coming out of the float tank. And now it's cut into sheets. The cutter runs diagonally because the glass is moving. Now let's load those sheets of glass up and take them to the windscreen plant. Here, an automated plotter moves a cutting wheel and scores the glass to the shape of one particular windscreen. Now, a torch moves along the score line and the thermal shock completes the cut. Now the glass is pushed against a series of sanding belts to remove the sharp edges. It's called seaming. Now the glass is cleaned with soapy water. Then sprayed with talc and water to stop it sticking to a second sheet of glass, which a robot now places on top of the first one. The two parts of one car's laminated screen have now come together for the first time. It's the obscuration band next. A black coating is silk screened around the border of the inner leaf of the screen. There are two reasons for this black border. One, so you don't see the urethane bead around the edge when it's installed. And two, more importantly, to protect the urethane bead from UV light when it's in the car. If you didn't do this, the adhesive would degrade and the screen could pop out. A visual inspection follows. Then, squaring up to make sure the two sheets are positioned exactly before they're placed on 4 metal pins that drop out of the way, lowering the glass into the bending iron. The iron is in the shape of one particular windscreen. The glass softens and sinks into the shape of the bending iron. Then it's slowly cooled, which makes the shape. Next, a robot cuts a piece of plastic sheet, polyvinyl butyrate or PVB, to the exact shape of the windscreen and places it on one of the glass pieces. Now the other piece is placed on top and we have the makings of a laminated screen. 2 layers of glass with a sheet of PVB between them. This 3-layer construction is what makes screens so safe in a crash. Although the glass may break, the PVB will hold most of the pieces together so that passenger airbags work properly and people stay inside the car. We haven't made a windscreen yet though, because you can't see through that milky white vinyl. It's got what's called a random surface grain, so the screen goes to a machine called the nipper, which uses rubber rollers to squeeze air out of the PVB. The air escapes and the grain collapses, creating thousands of little suckers that keep the two leaves together. The view through the glass is getting clearer. Now, a robot attaches the rear view mirror bracket. This blue machine is an autoclave. It's just like a big pressure cooker, and it gets rid of the last air pockets in the windscreens. Time for the final inspections now. Every windscreen is checked for scratches, chips, or contamination between the glass and vinyl layers. And then it's viewed under polarized light to check for stress defects. If all is well, it's ready to go to a car plant for fitting to a new vehicle.